We are delighted to present our candidate ranking system, a scalable recruitment intelligence solution designed to automatically evaluate and rank nearly 1 lakh candidate profiles against a predefined job description. Traditional applicant screening often depends heavily on keyword matching, which frequently overlooks genuinely qualified candidates while allowing irrelevant profiles to rank highly. Our solution addresses this challenge through a hybrid evaluation pipeline that combines rule based validation, semantic AI matching, behavioral analysis, technical capability assessment, and risk evaluation. Instead of simply identifying matching keywords, our system understands candidate experience, validates profile credibility, evaluates hiring readiness, and generates transparent, recruiter friendly reasoning for every recommendation. The result is a ranking system that is accurate, explainable, and scalable for enterprise level hiring. The first step in our pipeline is understanding the job description itself. Rather than treating the JD as a collection of isolated keywords, we organize it into meaningful capability groups such as ranking systems, retrieval, recommendation systems, embeddings, vector search, evaluation, fine tuning, and product machine learning. Once these capabilities are identified, every candidate profile is evaluated across multiple dimensions. We analyze their career history, including roles, responsibilities, protection, experience, and organizational context. Next, we evaluate their technical skills, considering proficiency, endorsements, and duration of experience. We also examine profile information such as the headline, summary, current designation, and years of experience. Finally, recruiter signals, including notice period, recruiter response rate, recent activity, salary expectations, and assessment scores. This provide additional indicators of hiring readiness. This holistic evaluation enables the system to assess candidates based on overall capability rather than simple keyword overlap. Ranking methodology. Our ranking methodology follows a structured multi stage evaluation pipeline. We begin with data normalization, where candidate profiles are standardized through schema validation, date normalization, and pre-processing. Next comes evidence validation, where we verify profile credibility by checking skill duration, consistency, education chronology, assessment scores, and career timelines. After validation, the system performs capability extraction. Relevant evidence is collected from career descriptions, skills, profile summaries, and headlines. Each capability is then scored based on ownership level, production usage, evidence frequency, recency, and role breadth. These capability scores are combined into a weighted technical fit score. Additional adjustments are then applied for experience mismatch, seniority mismatch, junior titles, intern roles, and title trap scenarios. The system further evaluates behavioral signals such as candidate intent, reliability, recruiter engagement, trustworthiness, and logistics. Risk analysis follows, identifying availability risks like long notice periods or inactive profiles, as well as domain specific risks such as consulting only or narrowly specialized experience. Finally, semantic similarity compares every candidate against a job description using pre-computed embeddings. All these components are fused into one comprehensive score and an optional cross-into stage where further re-rank the highest scoring candidates for even greater semantic precision. One of the strongest aspects of our solution is explainability. Recruiters should understand not only who was selected, but also why they were selected. For every shortlisted candidate, our system provides evidence such as matching technical skills, relevant projects, production experience, and hiring readiness. At the same time, the validation engine actively detects inconsistencies within candidate profiles. It verifies education chronology, checks career timelines, identifies unrealistic skill durations, and validates assessment performance. This makes the ranking process transparent evidence driven, and trustworthy instead of functioning as a black box system. As a result, recruiters receive recommendations they can confidently interpret and justify. End to end workflow. This slide summarizes the complete execution pipeline. The process begins by reading the candidate dataset, job description, and configuration files. Candidate profiles are then normalized and validated to ensure consistency. Next, technical capabilities are extracted and scored. Behavioral analysis and risk evaluation further refine each candidate's suitability. Semantic similarity computation measures contextual alignment with the job description. These individual scores are then combined using weighted score fusion. For improved ranking quality, the highest ranked candidates can optionally undergo cross encoder re ranking. Finally, explainable reasoning is generated for every shortlisted candidate before producing the ranked output. This modular workflow ensures both scalability and transparency throughout the recruitment pipeline. Our architecture is organized into functional layers. The input layer receives candidate profiles, job descriptions, and configurable scoring parameters. The processing pipeline performs normalization, validation, capability extraction, technical evaluation, behavioral analysis, risk assessment, semantic similarity computation, and score fusion. Supporting this pipeline are dedicated modules including the semantic index, configuration engine, explainability module, logging system, and parallel processing framework. The semantic index enables fast similarity computation through pre-computed embeddings, while multiprocessing allows efficient evaluation of large datasets. Finally, the output layer produces ranked candidates together with normalized scores and detailed reasoning. This modular architecture allows every component to operate independently, making the system highly maintainable, configurable, and scalable. Our system is designed specifically for large scale candidate screening. It efficiently processes approximately 1 lakh candidate profiles while maintaining deterministic and reproducible rankings. Performance is achieved through multiprocessing, pre-computed embedding indices, configurable weighting, and optimized score computation. More importantly, the ranking balances semantic understanding with rule based validation rather than depending on only one technique. Every shortlisted candidate includes not only a final score, but also transparent reasoning and identified strengths, enabling recruiters to make informed hiring decisions. Technologies used. Our implementation is built entirely using Python. For semantic understanding, we use sentence transformers, while NumPy handles efficient numerical computations. PyYAML enables configurable scoring rules without modifying the source code. To improve scalability, candidate evaluation is parallelized using Python's multiple processing framework. For deployment, we use Docker and Docker Compose to ensure consistent execution across environments. Embedding artifacts are managed through Git LFS. These technologies were selected because they support fully offline execution, eliminate external API costs, provide reproducible results, and scale efficiently for large data sets. Finally, this slide contains our project repository and generated submission file. The repository includes the complete implementation, configuration files, ranking pipeline, and supporting documentation, while the submission file contains the final ranked list of candidates generated by our system. Thank you.